Hello, good morning, guys.
Good morning, sir.
I will wait for 1 more minute and then we'll start.
Okay.
Okay, so I think we'll start now. So let me share the screen and let me know where you will see the screen. You're able to see the screen? Just reply. Hello.
Hello, sir.
Yes, sir.
You can see the screen, right?
Yes, sir.
Yes, sir.
Okay. So today I am connected from a Ubuntu machine. Okay. So I will be able to show you some hands-on programs so we can directly work on an Ubuntu machine without any other installation or services.
Okay.
So once again, I will just show the same socket programming itself. So we'll open two separate windows, and in one window, I will start the PySpark session, and I will execute the program. And in the other session, we'll start the netcat messaging system. And the same thing, instead of using PySpark, we can also launch with the Spark Summit. So we can see how in actual production environment, we will use Spark Summit to execute the programs. So how do we do it in a real environment is actually, we'll write a typical, for example, text.py, a Python program, which a PySpark program actually. So either whether it is PySpark or core Python program, whatever it is, the extension will be py.py. And how we are going to execute in traditional Python program using Python.space
Python dot space.
py.
Fine.
So here we will be using, if you are going to execute Spark, we will be using Spark service, the code first of all, then any arguments you have, argv1, argv2, and apart from that, if you are going to run in a actual cluster, you will have some parameters like number of executors, number of cores, like that, and the executor memory. So all these parameters will be there. So this is how we execute in the real environment. So we will write this Spark Summit code in a shell, typical shell executor any .sh file, for example, test.sh. So we'll create a shell script and write this Parsenet code in that, and we will schedule this shell script either using a scheduler like Uzi or some other scheduler. We can use Uzi or we'll use some other scheduler like or typical cron jobs in Windows Linux. That also will work. So first we'll see how to write the same program. I will just take that out. Okay. So when I launch this PySpark, I directly connected to Ubuntu for now. So instead of launching this, I can do one thing. We can disable this the launching of Ubuntu Jupyter Notebook when you launch PySpark. So for that, you can go to -rc. So here I have path mentioned for Spark and Spark home bin. Then I have the Python path is mentioned as Spark home/Python. Then PySpark driver Python and OPTs is mentioned Jupyter Notebook. So I have commented this now to launch the PySpark from Jupyter Notebook for time being because I need to execute from the shell. So what I will do is just closing the session. Let me open the terminal again. Okay, now since I commented that particular connection to Jupyter Notebook, it launched PySpark version 2.4.0 from the terminal itself. Now, in the another, we will open one more window. I will open one more small window here. So this is for executing get command. Okay, so nc -lk space port number. So I can type the words and everything here. So meanwhile, I will start write the program here. The same Spark structured string program to read the data from the socket with the port number 9999. The same program now issues no difference. I just so before writing this, you have to import split and explode function. So you have to import that. Okay. So wait code data frame is created, and then the next process is write to this on the console as a write string. So our Spark application will start, streaming application will start. Okay. Now we'll type the some sentences here. Still not taken. Now it is taken. But still hello is only one count. So we'll wait for the next iteration. So hello became 2. The count keeps on increasing. So I think hope you understood this one.
Yes, sir.
Okay. Now the same thing we can write into a file also, like I mentioned before. Okay. Before that, I will just tell you the same thing. Instead of running a PySpark shell, how we are going to run is actually using Spark Summit. So Spark Summit, you write a program into a Python file with a .py extension and run this. So for this, we can do one thing. I will go to the terminal, or it doesn't matter where you can go. Not an issue. I will exit from the PySpark shell. Now we don't need PySpark shell because I am going to my home. So in home, just I am creating a file called wc.py. Okay. Now I can copy this code and then code. Just remember that since you are writing an actual Python PySpark code, right? So you need to create a Spark version first of all. So I created the code completely. Now I can save. So wc.py is saved in this particular location. So now I can do this one. Please use this Spark Summit. So Spark Summit is actually in this particular folder. So we don't need to really go to the Spark Summit. We should be able to run from anywhere. So I am submitting this Spark application. I don't need to give the path here because it is already in my home. So once you submit, I think there is some issue. No such file or directory. didn't give the proper file name. wc.py, which is what I created. So Spark submit is wc.py. So it is submitted in Spark. So it will allocate all the memories and everything associated for this program. So Yarn will allocate all this memory, sufficient memory, and everything. So it will take some time when you submit Spark, when you submit the Spark application, because it's connected to the Yarn, get the resources from the Yarn. Then we set up the executor and everything. Then we start executing the application. So you could see this word. So in between you will see many things, because this is not the purpose of using Spark Summit. Okay. So in between the output you will see many logs and everything. Okay. So in real time we will not use Spark Summit to just to display the data on the screen. Mostly we will use on write the data to some external destination target. All these things for all this purpose only we are using Spark. So in between output will be displayed here. So in between level so many logs messages are we can see when you actually submit the Spark message. Submit is not like in a Spark shell. So this keep on running. So the console message and a bit difficult to read here. Okay. So for the time being, I'm just killing here. We'll do something different here. Okay. Now instead of writing the data on the console, we can do something. We can write this into a file, an external file, maybe in HDFS or in local. So you can see how to write this into CSV instead of outputting on the console. So we have some examples here mentioned. Let me open the file here, wc.py. Here, output stream format. option we have to format, we have to mention target and location. We have to write an HDFS location, or we can give our local files. So we just locally. So based on data frame, right string, output mode complete and format is C3 and dot start extension here. And then we see how it get executed. There was some error in the program. Data source C3 doesn't support complete output mode. So I think we have to use this point or nothing more we can write. Again, computer. Node is not defined. So here data frame dot write string dot format then option checkpoint location is mentioned and path is also mentioned. So either we can try using this particular way. dot write stream format. I will mention. The path to I need to write the file. Okay, we'll check whether it will work or not. I think this in some indentation errors. I'm not aggregating here instead of aggregation, and this will just print the words itself. Okay. So the program is running here, and I am inputting the lines here. So let's go and check uh, in my home folder. Are there any folder created for this? Let me open a new terminal. That will be better. Home slash. Okay. So the file is getting created. Getting not yet returning any data. In case if you want to check the files recursively in a directory, you can use shell R. So we can see all the files in this particular directory. So we have see this file like this. Data is getting created in this particular op.cc will be a folder first of all, and data is getting created in this particular part. So it gives us dfs minus dfs minus cat. So I'm just simply printing the. Hope you will be able to understand now. In this program, I am just printing the weights, whatever extracted from this particular here. Okay. So let's keep on adding into this file. So instead of if you just want to create only single file, you can do one thing. Now many files are getting created right in this part, in op.cc part. So instead of if you just want to create only single file, you can use a repartition. So repartition, I will just stop this program for now. Okay. So repartition is something like the data frame we have creating right. That data frame is actually have multiple partitions. Okay. By default. So when you write this data frame into a file, the file also will be having multiple files when you write into an output. So to avoid this situation, what we need to do is actually we have to consolidate all the data in a single file. So for that, what we do is actually we either use a repartition method or a coalesce method in Spark to consolidate, bring everything in writing into single partition. So that data frame will be partitioned into single one, and then only we are writing the data. So let's have a look at this repartition. repartition. So we can mention repartition of 1. Save this file. Now I will go back to my HDFS location. HDFS levers minus R minus R. I'm deleting this directory. So this directory is deleted. Sorry, directory is deleted. So we don't have any directory like this anymore. You can just confirm it. So we don't have any directory called op.csv. Now in op.csv, it should create only single file. So whatever the output we are going to write should write in the single CSV file inside that. So that is why we have added a repartition of 1 on the data frame. So now when you execute this one, you should have only that. Thinking. You don't see any output here because I'm sure that happened. There is some issue happened. I'm not sure what exactly happened. Let me just go and check the HDFS presentation here. There's created only one file, a single partition file, but somehow the application got crashed in between. So we'll see that later. What was the issue? I'm just switching back to multiple. I'm not doing the partition here. Okay. Now, there's another question here. Now, in this particular code, I am writing this localhost and port number hard coded. Instead of that, we can do something like, let's say, I will go and show you some program. So if you go to this code, this is the same code. Okay. Here I am not writing host or port number hard coded. Okay. The same thing we are doing sparse dot read stream from the socket. Host and port number is not hard coded. Instead of that, I am using a variable. This is the only thing I am doing here differently. How we are going to get it? Extract host and port from the arguments. So you can pass argument to this program as 1 and 2. Then host and port number will take read by from that. So how it is going to read is actually when you do a sparse submit. Spark submit program name space localhost space triple M. Got it. So I will do one thing. I will change the program similar to this one. Or I will create a new file wc1.py. Okay. Now I can simply run this sparse submit space wc1.py space localhost and port number. So let me change the file name here. My file name is wc1. So in my code, I am not writing anything, but instead of that, I am just simply passing this localhost name and the port number name as an argument, and the code will read that. How the code is going to read is like when you write the program, R01, R1 and R2. The first argument, second argument. First argument is assigned to host variable. Second argument is assigned to the port number variable. And this host and port will be passed to this particular function when you call. So you can pass any host name, any port number. It doesn't matter which port number you are passing. So this is how you need to pass the argument to a code, Python code. It should be similar to Scala and Java if you have tried some programs before. How we are actually passing the argument.
Yes, sir.
So now if you execute this one, it will almost get the same result. It's printing on data on the console.